Hi, my name is Pete Milgren. I am a professional data scientist, freelancer, and consultant. I have worked previously as a data scientist or data analyst for about 6 years now. 2 years professionally as an economist that did a lot of coding, 3 years as a data analyst for a Major League Baseball team, and now I've spent the last year as a freelancer and consultant. Today I'm going to walk you through a early project of mine as a freelancer. This was actually my first project as a freelancer. The client asked me to take some data stored in an Apache Hive database and convert that into a fixed width file. And if you don't know what that means, don't worry. I actually didn't know what any of that meant when I first applied for the contract. But I took the contract, I learned all of it as I went, figured it all out really quickly, was able to do great work for the client. Really just able to fall back on my skills as a data scientist and developer and Python coder. So I will walk you through how all of that went, what the client was looking for, where we ended up, and hopefully at the end of this video you'll have a pretty good idea of what it would take to take on your own contract on a site like Upwork and to be able to meet clients' needs using Python coding. So before we actually talk about the coding solution, let me provide some background on the project. So this was very early on in my days as a freelancer. I was applying to really anything I could apply to, anything I could find, and I did apply to this one position. The description was really vague. All it said was Python script for reading Apache Hive tables and extract it to files. So I knew how to write Python scripts. I didn't actually know what Apache Hive was other than I knew it was a SQL variant, and I did know how to write data from Python into text files. So I figured I could probably figure out the one part of this project I didn't know and do the rest of it to be able to meet the client's needs. I went ahead and applied. The client got back to me. He ended up hiring me. In the process of the client interviewing me, I did do a little bit more research to make sure I understood what Apache Hive was. And again, if you don't know what that is, don't worry, I will get to explaining it. As I talked to the client a little bit more before I accepted the contract, I wanted to make sure I knew what I was doing. So I really got it down to these three basic project goals. One, he needed to connect to a specific Apache Hive table he had on his system, and he told me he would not be able to give me access to that, so I would have to be able to figure out how to help him connect just by sending him the code, but I would not have the ability to test the code myself. Once he was connected, the client did need some minor changes made to the data that was brought in, and then once those changes were made, he needed the data exported in a different format. This would be a text file with fixed width columns, meaning that each column would have a set number of spaces. So different from a CSV where it would be separated off by commas, this instead would be separated off by having a fixed number of character spaces in each column for the data. So I figured I could do all of that. I'd be able to meet the client's needs, went ahead, accepted the project, and we got going. I also do want to talk a little bit about why I thought that I would be able to do this project. I did in the past have some experience with Python ETL type projects. Now, when I say ETL, that stands for extract, transform, load. If you're unfamiliar, that's basically a way of bringing data into something, changing, manipulating that data, and then putting it into another environment. So a lot of times that might be I'm going to bring in data from a website, manipulate it in a Python environment, and then write it to a SQL table. Or I have some data that stores a JSON. I need to convert that JSON data into a table format so that I can use it somewhere else, maybe store it as a CSV or something along those lines. So I had done ETL projects like that in the past using Python, so I knew that I could do a project similar to this as well. A lot of times as a data scientist, even though I think the modeling part of data science or the analytics part of data science a lot of times gets a lot of the attention, there is a big field of data science that has to do with being able to bring in and understand and work with data, being able to manipulate data and make it what you need it to look like. And this is really what I focused on in this case. This was an instance where I knew that I had done that in the past and I knew that I could do this for this client. It did seem pretty simple. It did end up being fairly simple, although, as I mentioned, the contract did over time lead to a lot more work and become much less simple. But even then, because it was built on a foundation of things I knew how to do, as the client's needs evolved, I was still able to meet those needs, in part because of the experience I already had, but in part because of my ability to learn and to research and to figure out how to do things that I didn't know how to do already, and that was just built off of having a solid Python foundation. So we'll get into all of that today as we start to walk through the project and how I met the client's needs. So we are about to talk about the solution, but before we do that, we have one more piece of housekeeping to take care of. If you want to see the files for yourself, you can find them on my GitHub. That site for this repository is github.com/pmelgren/hive2fwf. So PMELGREN/hive_2_FWF. This is really a really easy way to get all the data in front of you. You can actually fork this repository yourself and begin to make changes to it, maybe play around with it a little bit, or at the very least you can download this and have the files in front of you without having to type them up from hand. You can bring them into your own Python environment and be able to try running the code for yourself. Okay, so we've talked about the client needs and I've shown you where you can find these files for yourself. So let's finally start getting into the actual Python solution. So this right here, we are in the Spider environment. If you aren't unfamiliar, this is my favorite environment to do data science in Python. Really, it's personal preference which IDE you want to use. That's not a big deal. However you want to look at your Python code is totally fine. Just in case you're wondering why does my screen look different than yours, I am using Spider. So this here, we have all of the code we need is in one file. We'll quickly kind of go through the main parts of this file and then I'll break them down each. So like I said, there were 3 requirements. We needed to bring the data in from Apache Hive. We needed to do a little bit of manipulation on the data, and then we needed to be able to export that data as a fixed width file. So what you'll see, the way this file is set up is the first section, we have a couple of small little functions here. These are functions that can be easily updated based on the user needs. So this restructure, this is actually what ends up doing the manipulation to the different columns. And then this function here, get query text, this is the query text for the Apache Hive connection. We'll get into all of that later. We next have these ETL functions. We've talked about what ETL means. So this Hive to data frame, this is the one that reads the data from Hive and is going to bring it into a pandas data frame. And we'll talk about what pandas is as well. And then this one, to FWF, this will take the data and export it as that fixed width file in the proper format that we need. So these are both functions. If you were to run these, nothing would actually happen, but you can call these functions from another command and something will then happen. So down here, this is the part of it. I actually only have 2 lines, 2 actual commands right here with comments, and that is this df equals pd.readcsv. That's going to bring in the data, and then df.restructure.toFWF. So 2 lines right there. You don't need to know what they mean yet. We'll figure that out, but that's the entire thing. Everything else is done in a function. And now let's start talking about each of those functions and what they mean and how they led to the solution to this problem. We have our overview of the project, so let's go ahead and dive in now. We're going to begin by looking at this function, def hive to data frame right here. These are the arguments for it. The whole function is right here, all these highlighted lines. This is the function that is going to connect to our Apache databases and then bring the data in from those. In order to do that, we need to write some sort of a query to bring that data in that we need to connect to Apache. Now this is where things are going to get tricky because at this point I don't even know what Apache is and I don't really know how to connect to it. So I had to go and do some Googling to figure out what Apache was and how to connect to it, and let's talk about that now. Now Apache is essentially it's just another type of SQL. It's another SQL variant. You may have heard of MySQL or PostgreSQL or maybe Microsoft SQL, anything along those lines. Those are all, at the end of the day, they're basically the same thing. They're slightly different iterations of the same thing, and that is a server that hosts data and you are able to use SQL to access that data. So this client, his company happens to use Apache. It has some advantages and disadvantages. I don't really know what those are, to be honest. I didn't need to know for the scope of this project. All I needed to be able to do was figure out how to connect to an Apache table. But again, unfortunately, I wasn't actually given access to that Apache table. Instead, the client was able to send over this document right here. Now, this document is a create table statement for Apache, and this was the data that he wanted me to connect to. Now, this wasn't the actual data. This is some data that I faked in order to be able to do this for you guys using without having to actually reveal any of the client's data or any identifying information about the client. So this is what it looked like, or this is what it would have looked like if it was based on the fake data that we're using. Essentially, it is if you're familiar with SQL at all, this is a create table statement. If you're not familiar with SQL, you don't need to worry. What's really important are these 5 lines right here. This tells me the columns that are in the SQL table and what their data types are. So the first column is account number, and that's an integer data type. The second one is amount, and that is a decimal data type. You'll see bonus, which is also a decimal. You'll see item, which is a varchar. Varchar essentially it's similar to a string or a text type character in other that you might be familiar with in Python. Essentially, it stores text information, and then date is also a varchar. Now there is a date data type in Apache, but in this case, the way that the date information was being brought in, it was being brought in like a string and not like a date. So that was clearly going to be a challenge, and that was one of the things that the client was also going to ask for me to make a change to. Eventually, I was going to be converting that date to a different format. The rest of this isn't really very important to what I needed to do. In fact, I didn't end up paying any attention to the rest of it. All I really needed to know, again, were these 5 lines right here. What are the columns and what are the types? Because knowing that information would allow me to write a SQL query that would eventually allow me to send that to the client and he'd be able to connect to his data. So because I didn't have access to the table, I needed to basically look at documentation to try to figure out how I was going to be able to connect to this. Now the client did specify that I use something called SQL Alchemy, which is a pretty common package in Python. SQL Alchemy essentially is a package that allows you to connect to different SQL databases. So like I mentioned, SQL, MySQL, PostgreSQL, Microsoft Server SQL, all different things that are supported by SQL Alchemy. Hive, unfortunately, is not directly supported by SQL Alchemy. So instead I had to come to this, there's an intermediary package called Hive. So I'm not going to type a lot of code today, but I will show you guys how I installed Hive. Very simple, using the pip install. If you're not familiar with this, we won't get into it too much, but this is how you would install a new package in Python. So I had to go in and install Hive, and we'll sit here and watch. I already have it on my computer, so this isn't going to be very interesting. But just type the pip install Hive command. Hive is already on my computer. Great. Okay. So we have Hive on our computer. Now what we need to do is to figure out how to connect a SQL Alchemy engine to a Hive database using SQL Alchemy. So in SQL Alchemy, you create an engine, and then every time you want to connect to a database, it uses that engine to actually make the connection. So in SQL Alchemy, there is a command called create engine. That's what we're seeing here. And then you have to use that command and a certain connection string to be able to connect to a certain database from a certain type of SQL. So because SQL Alchemy doesn't have native support for Python, instead we are getting this from the PyHive documentation. You can see up here, once again, I'm on GitHub. This time I'm on PyHive's GitHub. And we are taking a look at how to connect a Hive database using the SQL Alchemy create engine syntax. So our client did have he needed the option to have a username and password. So we can't use this syntax here because we do need the username and password. So instead we're going to use this syntax here. So this is a really good example of how to handle something that you don't necessarily know how to do right away. A big part of being a developer, a big part of being an analyst or a data scientist is to know how to Google things and know how to find answers really quickly by Googling things. So that's what happened here. I didn't know how to connect to an Apache Hive database, but I did have some familiarity with SQL Alchemy and with Python, and so I knew that I could probably figure it out, and that's exactly what I did. I did a little bit of Googling. I ended up on PyHive's website, or PyHive's GitHub, and that's where I was able to see, okay, this is how I need to do it. So we're actually not going to put the connection args So we aren't going to put the connection args option into our code. We're actually only just going to use this line right here. So this hive //user password at host 1000 /database. And just to break this down a little bit, so this is something that I knew already, having had some familiar with connection strings. Each of these represents a different piece of information that is needed to be able to connect. So Hive, this is the driver essentially. This is what the connection string recognizes. Okay, we're dealing with Hive. We're not dealing with Postgres or MySQL or anything like that. Username and password separated by a colon. And then this at host, that is the host name. It's a characteristic of the server. This is the port. We do not need to get into what ports are, but for Hive, 10,000 is the port number, and then the database. This is the name of the database within the server that you're connecting to. So we're bringing all this in, and obviously the client's username is not user, the client's password is not password, the client's host name is probably not host, and the database name is almost certainly not database. So I'm actually going to have to change each of these different things to what is specific for the client. And instead what we actually ended up doing was not doing that, but making it into a function. Okay, we have all the context we need now on SQL Alchemy and Hive and how to connect. So let's take a look back at our Python code and go through this line by line in order to be able to understand what's going on here. So this function right here, we've already shown you this. This is Hive to data frame. So this contains the connection string and then the data to bring it in. We'll start off with this line right here. Engine equals sa.engine.create _ engine. This SA comes from my import statement at the very top. I think I skipped past this pretty earlier. Right here we see import SQL Alchemy as SA. So that means whenever we need to call a function from SQL Alchemy, we are beginning that with SA, just a shorthand since we've imported it that way. Now engine.create engine, that's the actual function we're using. We already saw this from the PyHive documentation. So you'll now recognize each of the parts that I walked you through earlier. They're now broken up for the most part by variables. So instead of, this remains a string, but instead of being a string, user is now a variable. Password is a variable, host is a variable, DB is a variable. We are keeping the port the same, and this @ sign is always going to be there, so we didn't need to change that. So now the user is able to call this function with the user, password, host, and sample data, or sorry, and the DB argument, and they should be able to connect to the database that way. Now there is a little quirk where if you don't have a password and you leave the password argument blank, there's not going to be a colon, so that colon only needs to be there if there is a password. We can actually go back and look at the PyHive documentation to see what I'm talking about here. So you'll see when there is no user, there's no colon after it, but when there is no password, there's no colon after it, but when there is a password, there's a colon between user and password. So in order to be able to handle that, I put in this small little if statement here. So if password is not blank, that's what this line, if password is not blank, then we are going to put a little colon in front of password, so down here, user and password will be separated by that colon. So now that we have so this line creates that SQL Alchemy engine, which you've already talked about. Now that we've done that, we actually need a query. We're connected to the database, so we need a query to actually be able to pull data from the database. So that's where this line comes in. Get query text, this is a call to a function above, and this is one of those other functions I talked about earlier, one of the ones where the user can come in and easily change it. So this right here, all this function get query text does is store the query text, and this is what it looks like right here. Select from limit. If you know SQL at all, you probably recognize this syntax. These are the names that we already saw earlier when I showed you the create table syntax that the client sent me. So now everything is coming together. Now we know how to connect to this client's database. We know the names of the columns and the structures of the columns in the database, so we should be able to write a query to connect. The last thing here, this line, df equals pd.readSQL and then query text and engine. So PD, if you aren't familiar, this is the very common shorthand for pandas. So let's go back up to my imports. The very first thing I import here is pandas. Pandas is probably the most useful package for data science. I don't think that's a very controversial statement to make. Basically, it allows you to use data frames, which are it's like in a table structure, but it can store a variety of different data types, and a really great way to store data for data science. So we're using that in this case because it has really easy functionality. This read SQL statement from Pandas, if you have a SQL Alchemy engine, which is what we have right here, and some query text, it'll bring data in straight from SQL and bring it into a data frame. So this last line brings that data in from a data frame using the pandas read SQL function. And then this function, once everything is brought in, will return that as a data frame. So now let's go back down to the bottom and see where we actually call this function. So you'll notice that you don't actually see it anywhere. That's because it's commented out. As I described earlier, I can't actually connect to these databases. So if I were to run this on my own, this would be the right syntax right here. But if I were to run it on my own, I would receive an error. So let's go ahead and do that just to take a look. It's going to try. Okay, no module named thrift. If we were to go back through this traceback, we're not going to do it. It's going to take a long time, not worth your time or mine. If we were to go back through this whole traceback, what we would see is that it's not working because I'm not connecting to anything because I don't actually have access to a Hive database on the host name that I provided or the port, and the user is not real, the password isn't real. Even if there did happen to be something there, I would probably not have the right database name. So this is where we get into the idea that even though I needed to help the client connect to Hive, I couldn't do it myself. So instead, I just had to send this client. I had to take my best guess as to this is the code that will help you connect to the database and then send it to the client. And because I was able to look at the documentation and understand everything, it actually did work for the client. I didn't have to do a lot of troubleshooting. The documentation was really clear. It was pretty straightforward. All I had to do was put the right stuff, did go ahead and double check, cross every T, dot every I, and make sure there wasn't a dumb syntax error in there. But I did have everything handled as it needed to be, and when I sent it over to the client, it did work for him. But I still needed something on my end so that I could actually bring in the data myself. So instead, I am using this, when I run it in my own environment, I'm using this line here. This looks very similar to what you've already seen. Instead of df equals pd dot read SQL, which is the bottom of this line, this is just read underscore CSV. Slightly different syntax. Basically, instead of bringing in the data from a SQL table, we're bringing in the data from a CSV file. And that CSV file is stored in this file location right here. If you haven't seen this before, this dot dash, this just means, Python is always going to have a working environment. This dot dash right here just references the working environment, and then within that working environment, there's something called sample data. So let's pull that up. This is the working environment. This is my project file for this project, and what you see right here is we have this sample data.csv. So read underscore CSV referencing this file path for sample data.csv. This just indicates that it's being separated by commas. It's comma separated. And then once I do that, I'll be able to bring in the actual data. So let's do that now. Let's go ahead and bring in the data and take a look at what it looks like. I'm going to do that in the console over here. So if I just highlight this line, hit Control Enter, it'll run it. And now I can look at this data and see what it looks like. Let's make this a little bit bigger. And we're saying, okay, this does look right. However, it's only showing us 4 columns out of 5. What we need to do is use the PD set option and display max columns. And we'll go ahead and do that. I'm going to actually pause the video for a second so I can look up the syntax. This is one of those examples. Every time you need to do something, it's just so easy to Google. It's so easy to find this information right away. A lot of times I don't remember some syntax that I use every day just because it's so accessible. Okay, sorry about that. So pd.set underscore option display.max columns comma none. This is the line that you can use to make sure that you display every column when you look at a data frame. So let's do this again. df.head will show us it's called the head of the data frame, or just the first few rows of the data frame. Having changed this option above, it should now display every single column in the data frame. Perfect. So that's what we expect it to look like. This looks the exact same as the CSV that I pulled in, which was based off, the client did send me a CSV of the data because I couldn't connect to the data directly. So this example, or this would have been the CSV that the client sent me. It's now been brought in using Pandas. So this is a Pandas data frame. Let's take a look at these different columns. We have an account number, an amount, which is a number, bonus, which is a number, item, this appears to be text of some sort, and then date. This sort of looks like a date, but it's in a weird format. It's got this little T here in the middle, and then every time is exactly midnight. Odds are that's not the actual time. That's just, it's displaying it as a date time, when the only thing we really know is the date and not the actual time. So now let's get into the manipulations. So the next thing we do is, after we've brought in the data, we have to manipulate it a little bit. That line in our final script is this dot restructure. So we actually do two things in this final line. The first thing we do is restructure. We're calling this restructure function. And so we see that up here. So restructure takes an argument, df, that means data frame. And it does some manipulations. And then it returns this line right here, df.lock, colon, comma, call underscore order. We don't really know what that means yet, so let's dive into it. So we bring in this data frame. What we're going to do is we're going to feed it this exact data frame, so we know that we can reference columns by their specific name, so that's what we do here. When you have this brackets and then a word inside of it, that is referencing a column. In this case, df capital date, where all the letters are capitalized, doesn't exist yet. So I'm actually creating a new column, and I'm creating it based off of this line right here, the right-hand side of that. So you see here again, df date, this time date with lowercase ate in this brackets, that's referencing a column that does exist. So it's now going to bring in that column and then do some manipulations to it, and those manipulations are done by this. So we're seeing here is this dot apply lambda x colon and then some other stuff. You actually see that in both of these lines. This is a really easy way to change an entire row of data in a data frame using some sort of logic. So what we're doing here is, this is called a lambda function. And lambda functions are really, really, really powerful concepts in Python. Something that we're not going to, I could probably make an entire hour-long video about lambda functions. I would really strongly encourage you to look those up and to understand what they do and how they're used and why they're so powerful and they're so popular. In this case, basically all you need to know though is that a lambda function essentially creates a little like sub-function within a larger function. So if that seemed really jumbled, what it's doing here is it's applying everything to the right of the colon to this x right here. So what we're doing is we're taking whatever x is and then we are applying this to it. So in this case, x 0 to 10 dot replace. We'll talk about what all of that means. But so that would work for one. In this case, x would be one string or one row of the data. But we also need to apply it across the entirety of the data frame. So now this dot apply, this is what does that. So basically apply takes a function and it applies it to an entire array. In this case, the entire array is df.date. So let's go ahead and look at our console and kind of see what that looks like. All right, so I type in df.date and what I get back is basically all of the contents of the date file. And it cuts it off here because I don't need to see 150 rows. I see 60 and that's plenty. Right, so this is what we're looking at. Each of these is one item in an array. Right, so let's actually do that for example. So we're applying this we're applying this lambda function to every single item in the array at the same time. And we could also accomplish this with a for loop, but for loops are really slow. They're not nearly as powerful or robust as using an apply statement. So if you're going to apply the same exact logic to an entire array like that, it's always better to try to use an apply function or a map or something like that as opposed to using a for loop, just because for loops are very slow. So to understand what's going on inside of this apply, let's maybe take a look at this and let's just try it out on one row first. So like I said, lambda x, this just indicates that you're going to kind of apply a little baby function to a certain variable x. So everything to the right of here, that's what we're interested in first. So let's take this row of, the very last row of our date column. We're going to treat it like a string because that's what it is here. And then let's do the rest of that. So 0:10 dot replace, and we were putting this hyphen in quotes and replacing it with an empty quote. And let's take a look at what that looks like. Oh, so what we get back is just 20190828. So that's interesting. Why does that happen? So the first part of this, so this right here is a string object. If we were to just type this into our console, it would return itself, right? It would just recognize it as a string object and print out that string object, right? The rest of this, these are all functions. If I were to put all this into the console, it's going to return an error because it's going to have no idea what I'm talking about. Or it's looking for something and expects me to give it something else. And then I don't give it something else. It's like, well, this doesn't work. What's going on here? That's because these are functions and this is an object, right? So we're applying this function here to this object. And what this function is, this right here, this is basically calling the first 10 items of this string. Now, in a lot of other languages, strings are treated like a single object, but in Python, strings are actually treated like an array. So you can reference an item of a string the same way you can reference an item in an array. Let's take a look at that. df date is an array. We've already seen that. So what happens if I just reference the third item in that, which I'm going to use 2 because we're 0 indexed here? It gives me the third item of df date, 2019-07-23, right? Oh yeah, exactly. That's what we expected to see. So what happens if I am to reference the third item of that? So let's just put another bracket 2 on that and see what happens. Oh, 1. So now what are we seeing? Each of these characters, character 0, oh sorry, character 0, 1, 2. So when we reference item 2 of this, we returned the item in slot 2, which is this 1. So basically what I'm trying to demonstrate is that when we apply some sort of we apply an array index to a string like that, what we're going to get back is the items in that position. A lot of other programming languages might use something called like a left or a right function, but this is even so much simpler than that. This is one of those reasons that Python is so popular and so powerful. We can really easily access anything within a string just by using the same bracket syntax that we use to access anything in any other type of array. So let's take a look at that now. So go back up here and take a look at what happens when we just do this 1 through 10. What does that look like? Okay, so it gives us the first 10 characters, which are these 10 characters. So that's the date. Then everything after the T goes away. Taking a look at this data, we can see that it's formatted in a date format that's consistent, so we know that the first 10 characters are always going to be the date no matter what. So we're comfortable doing that. We can get away with that. So now what's up with the second half of that, the dot replace? So what this does is, now let's get rid of the slicing and let's do a dot replace. So replace, you may know this from other languages as well, or if Python is your first programming language, it's a pretty simple concept, something that if you don't know already, you'll pick up really quick. This finds this item in the string and replaces it with this item. So when we do this dot replace, what do we get? It's the exact same thing, but all of the dashes have been replaced with this, which is an empty string, which is nothing. So when we put those two together, what we get is the first 10 characters only, and then all the dashes have been replaced with empty strings. So first 10 characters only, replace the 2 dashes with empty strings, brings it together, looks like this. Great, makes perfect sense. So now let's come back to this, and this is pretty in-depth. This is a pretty simple project, so we have a good chance to go in-depth on this. And these are probably 2 of the more interesting lines of the project, so that's why I'm going so in-depth on these 2. So let's come back to this. So we see that now we're applying, so this lambda x, again, it's taking everything, this kind of syntax here, apply lambda x, and then a colon. That's treating everything within this array as a single line or a single object argument, and then x is kind of standing in for whatever that object is going to be fed in through. So essentially what we're doing is we're taking all of the items in this df date and we're applying this function to it. And so what happens when we run this single line, now let's take a look at df again. Okay, so what we see is we now have this new column, it's capital date all in all caps, and it's what's coming from date here, but it has no dashes and nothing after that T. Right? So that's perfect. That's exactly what we were hoping for. Okay, so now let's take a look at the other line in the restructured function. So we have this line right here. We already recognize a lot of this, so we see df of account number, that's referencing the account number column of that data frame. Dot apply lambda x, we already know what that does. So now all we really need to do is dive into this part here. What you'll notice is the x this time is right here, so once again that is standing in for the variable that we're applying this to, which is each individual line of df account number. And before we go any further, I actually just caught a little error here, so we will get that taken care of, make sure that we do not have any errors for when we do finally run this. So let's figure out what exactly is going on right here. So let's bring that over here. Again, we know that this x is standing in for each individual line of df account no. So let's just copy one of the lines from df account no and replace it with x. Okay, and what happens when we hit enter? That's interesting. So it's the same number, but it just has 5 leading zeros in front of it. And if you also pay attention, you'll see these 2 little single quotes around it. That's representing that this is now a string. So instead of that being recognized as a number, it's now recognized as a string. So let's dive into what exactly is happening here. So this string right here, or we can look at it in our code here, this string right here, is essentially telling us that we need to take this number and apply specific formatting to it. And this is a formatting code, this jumble of colon zeros, this little caret 10.0f. What's really important to understand here, we don't need to dive into how exactly to create these formatting strings, but what's really important to understand here is this basically indicates that we're going to put zeros in front of the number until we have 10 total digits. So that is necessary because the client specifically asked that all the account numbers have 10 total digits in them. What we see is that most of the account numbers appear to have 5 total digits, some have 4. So in order to get them all up to 10, we just have to give them so many leading zeros, and the way to achieve that is to use this right here. And then this is .0f, this indicates that we are using 0 decimal float precision, which is a fancy way of saying there's not going to be any decimals in the number. So just for an example, if instead we were to change that to .2f, what would happen is we would have 2 fewer leading zeros, and then we would have .00. So actually we had 3 fewer leading zeros, sorry, because that dot counts as one of the 10 characters we're allotted. So basically what we have here is by setting this to .0f, we're ensuring there's no decimals, and this 0 is greater than 10 looking thing, that indicates that we have to have 10 total characters. Now that we understand what that line does, let's go ahead and run it and see the effect it has on our data frame. Let's just look at df here again, and okay, so we see this account no column in all caps. Everything has 10 characters. They're all the same size, so we can go back down and see one of the instances where, oh, here we go, right here, these 2 lines. So 65997, that's 5 characters, 3949, that's 4, so the number of trailing zeros is different. We didn't just add 5 trailing zeros, we got it up to 10 total characters. That's what the client was looking for. So great, so we've now restructured those two columns. The last part of this restructure function right here, we have this call order. So what this is doing is this is just creating a list of column names, and we will feed that into the data frame to tell it this is the order that we want the columns to be in the data frame. This again was specified by the client, so we just have the newly formatted date, the newly formatted account number, and then the item amount and bonus that were read in originally. And this line df.lock here, this tells you this is how you are selecting items from the data frame. So when you have this colon, that means you're selecting, well, sorry, the order of .lock is it's rows, comma, columns. So this colon means you're selecting every single row, and then this is specifying the columns. We're selecting these columns in this order. So we're returning data frame, all rows, these columns in this order, and we return that back to our function below. So now the only part of our code left to talk about is this toFWF function here. So let's go back up to where that is defined, right here. And let's take a look at what we're looking at. You'll notice, I don't think I talked about this earlier, but you'll notice that I do provide this documentation on every single function. This is just a quick way to give anybody looking at the code an overview of what's going on. You'll see these triple quotes here. Python will recognize triple quotes after a function definition like this. It'll actually show up if somebody's trying to use it. I think I might be able to demonstrate that. Let's just do that really quick. Okay, now if I come over here, let's see if this will work or not, but no, okay, it didn't work this time. But a lot of times, or if it compiles in a certain way, then when you type in this toFWF, it'll actually, if you hover over it, it'll actually have this text come up. So that's a good way, especially if you're building a package or something along those lines, to be able to let anybody understand what's going on with your package. And this style, it can be any style. I think I use the style that they use at Google, which you can find online. There's a million different ways to do it, I'm sure. Whatever works for you, whatever works for your client and whoever you're delivering it to, it's just worth noting here, documentation is really important. So we've gotten that out of the way, so let's talk about this toFWF function and what it does. So you'll see the three arguments here. It takes a data frame, takes a file name, and takes a date string. The client specifically asked that the data be output in a fixed width file format, and we'll take a look and see what that actually looks like in a minute. He also wanted there to be a header and footer on that file. The header, he wanted to have some text followed by today's date in a certain pattern, and then the footer, he just wanted to have the number of lines in the file. So we start off here taking the date string, datetime.datetime.today. If we type that in, that will give us today's date, but in a really weird format. So then we have to go ahead and format it, which is what this here does. So we can do this whole thing. Okay, great. And I'm casting that as a string, and it looks like here it did return as a string. So this str may be unnecessary. When I put it in, I'm sure I put it in for a reason. I probably tried it without it and it didn't work. So next, we have the date string. Now we're going to go ahead and actually create the output file. So this line here, file equals open. This W argument, if this file already exists, it's going to overwrite it with a new file. Encoding equals ASCII. That's just to indicate that we're using like standard text encoding. Fname, that's the argument from up above, so that's the actual name of the file. And you'll see down here I define that as being just test fwf underscore 2019.txt. So we're opening a file with that file name, overwriting any contents that are in there using ASCII encoding. Now we're doing file.write. So here's the header that we're writing. Just as an example, sales info underscore date string, which we created up here. And then this /n, if you've seen that before, that's an end line. That's pretty consistent across languages. Actually, that tells a text file that we're registering a new line. We're going to go on down to the next line. So if we print this whole thing, we would have sales info underscore 2019 0830, and then it would go down to the next line. The next thing we need to do, here's really the interesting part. We are writing the data frame onto the file as well in that fixed width format. Before we do that, there are NAs in the data frame. So this little line right here, df.replace np.nan with an empty string and regex equals true. All you need to know about this line, what it does is it takes any NA and it just turns it into an empty string. So if I look at my data frame now, actually I don't think that there are NAs in my example data, but if there are NAs, then those would be replaced with an empty string so that it wouldn't show up as NA in the final text output. And then once we've done that, this line right here, this is another instance where I didn't really know how to do this when I first took on the project, but it was something I just Googled and found a working code and made it work. And I left headers in. I had a headers argument at times because I needed to troubleshoot some things, but I did comment it out. So this is an example where commenting something out instead of deleting it, it's maybe a little bit less clean, but it does make it more apparent, or it does help you as you're troubleshooting, and may help the client too. If they're using this code later and need to troubleshoot, they can just uncomment that and look at the headers themselves. So you'll see that the headers here have been commented out. That means that we're going to write this as a fixed width file with no headers. These different arguments, these all come from the tabulate package, I believe. You'll see that's up here in our import statement. So this is coming from the tabulate package, writing it in such a way that we'll end up with fixed width files. Don't need to get into the arguments. It's just something I was able to find by doing some quick Googling. Again, probably the single most important skill as a programmer is to know how to Google things. So found that, setting it to a variable called content, and then we're writing all of content to the file. So now we've written the header to the file with an inline, we've written all of the content to the file, and then the last thing, the client wanted a footer that just represented the number of lines in the data frame. So we're adding one more inline to write the last line, plus the length of the data frame as a string. In this case, length will return the number of rows. So let's just try that out here. 150. If we do string of len of df, it'll be 150 with single quotes around it to represent that it's a string now instead of a number. So we write that, then we file.close, and now we have written the file and closed it. Should be saved. This line right here, this takes the toFWF function and makes it a property of a pandas data frame, which is how we're able to write df.toFWF. There's also one of these below the restructure. See this here as well. Both of those lines just take that function and make it a function that you can apply to a copy of a data frame. And so the first argument, the df argument, is actually inherited from the data frame that it's being called as a property of. A little bit of an advanced programming concept, something you don't need to get into. We could just as easily call toFWF with the first argument as data frame, but instead I do it like this. Okay, so we've covered every single part of these two lines here. So now I think the best thing to do, let's just go ahead and run it and see what the output looks like. Let's do that right here. All right, and let's open up the file. Again, we wrote it to this .dash, which means the working directory, which in this case is this right here. Test FWF 2019 created 1 minute ago. Let's open that up. Let's take a look. Ah, interesting. So now, if you weren't sure what a fixed width file means, you can see it very clearly. You can see that each line or each column occupies a set number of space within the column. So first thing we're seeing here is, every single column is the same length. We don't have the headers, so we'll just have to kind of remember, oh, this was the date that we formatted in such a way, this was the account number that we formatted in such a way, this was the item column, this was the amount column, this was the bonus column. And we can see again, like on the item column, some of these are significantly shorter, so if this wasn't a fixed width file, if it was a CSV, then this line right here would be moved over, but because it's a fixed width, that means that it knows to make sure that these all start at the exact same character number. You will notice that the first and last line are not fixed width. That's because we wrote them separately. We created the fixed width output just for the data frame, and that was per the client specification. Also, I think one thing I did not mention is the client wanted the footer to start with the number 3 and then to contain the number of rows. We can actually see that back here in the code. So this dash in and then the 3. So the inline followed by the number 3 followed by the number of lines. And that's what we have here. Inline, number of 3, number of lines. And this is what the client was looking for. So now we have roughly a script and the output for what the client needed. The only thing we don't know about is, well, does the, remember we had to read in a CSV. So we're reading in this CSV right here, the sample data.csv, but the client is actually going to want to pull that in from their Hive data or their Hive SQL instance. So the only thing we don't know about is, will this be able to connect successfully? And that's where I delivered to the client, explained to them how to make it connect. In this case, I actually got the connection information from the client, so I would have delivered it like this, left my line, commented out, and then had this line here active and said you need to go in, make sure that you change your user, all of your connection information to what it needs to be. And then once you have changed all that information, you can try it out. If it connects and you get the output in the way that you're expecting, then you know that it works. That's about it. Okay, so just to recap, I know that sometimes it can be really hard to see the forest from the trees for something like this. We've gone through a bunch of lines of code. We've gone through parts of lines of code. So let's back up a little bit, just take a big picture view again of what this script is, what it does. Now that you've maybe seen everything, it might be a little bit easier to put everything together. So, again, we've got these functions up here, the ones that the user can easily manipulate. We've got these functions here. These are the ETL functions, and then down here is the main script. We'll start with the main script. What do? We start off by creating a data frame that we're bringing in from some data source. In this case, that data source uses the Hive to data frame function. That's the one we talk about, where we connect to a Hive data frame using SQL Alchemy. We use this query here to bring in the data that we want to bring in, and then we return it as a data frame. So great, now we have a data frame. What's next? Next, we want to restructure that data frame. So we have df.restructure. So what does that do? We go in, we have all the data exactly as it appeared in SQL. Now we're going to come in, we're going to create these couple of new columns that format the data a little bit differently. Once we formatted that data a little bit differently, we're going to reorder the columns according to this order and then return that. So df.restructure returns a new data frame that has been restructured, and then this new data frame we're writing to a fixed width file. That's where we come up here with this to_fwf function here. Again, write the header, write the output as a fixed width file, and then write the footer, and then we are good to go at that point. So there, really basically does three things: brings in data, restructures the data, outputs the data. That's not exactly what ETL means, but that's essentially how ETL tends to work. You find some data, you put it in the format that you want it, and then you put it into you load it into a new environment. And so that's exactly what we're doing in this process. The client called it big data, but in essence, we were only working with about 100 rows of data. So maybe the client is performing on millions, if not more, of rows. But this example, it's efficiently written. It should work pretty well for what we're doing. There are certainly things that if we're getting into billions, if not trillions of rows of data, that we could be changing to maybe make it work more efficiently or make it work more viably. But that turned out not to be the case. The client kept things pretty accessible and in a pretty accessible size. So when I delivered this to them, it gave him what he needed. And then, as is often the case with a freelancing contract like this, the client came back to me and didn't say, okay, great, let's go ahead and close the contract. The client said, hey, this is really good. There's some other things we need done. Can you continue on by doing this step? Can you continue on by doing this step? Can you write this process? I eventually, the final output, I wrote multiple processes that did a lot of things. We did a lot of restructuring, worked with a lot more columns. We actually ended up writing 3 separate processes. It was a very long, involved, ongoing project. But it all kind of started with this, okay, I met the client's simple initial needs and they were happy with it and they were able to move on to more complicated stuff, gave me a lot more hours, helped me make some more income, and it was a win for everybody. So the last thing I wanted to talk about was just a couple of takeaways from this, not only as a programmer but also as a freelancer. The first thing that was really surprising about this project is how much it evolved. How much, like I said, this was just the first step, and the project ended up lasting multiple months. I worked hundreds of hours on it. It was a very different project than the initial requirement. When the client talked to me about it, he asked if I could have it turned around in about a week, and I ended up working on it for over 5 months. So I think in a lot of cases, it's sometimes hard to tell. You don't know which clients have one very specific need or which clients might have this evolve. I've taken another project on Upwork where the clients asked me to build a simple Excel report, and I built a simple Excel report, and then they're happy with that. So they say, oh, hey, here's the other 4 or 5 reports that we want done. And so, just like that, what might have been 10, 12 hours of work might be easily turning into 40 or 50. And those are always good things. It's just always the value of, a lot of freelancers might say, oh, you only want to take, you don't want to take these small contracts, you want to take big contracts, stuff that is more sustainable. And I would agree with that. But at the same time, it's sometimes hard to tell which of these small contracts might turn into big ones. And no matter what the contract is, it's just a lot of value in doing good work, because if you do good work, it will, eventually pay off for you. Um, Another thing that I figured out was that I was selling myself a little bit short. Like I said, this was the first contract I took on Upwork, and at the time I was asking for an hourly rate of $45 on my profile, but I only had the confidence to bid 40 for this project, so 40 an hour for this project. Um, when I put in the bid, and the client talked to me, and he was happy with my when he was interviewing me, he was happy with me, so he decided to open the contract. He went to my profile to open a contract, which is how it works on Upwork. He saw my hourly rate of 45. He didn't even consider what the original bid was, just gave me the hourly rate that was on my profile. In a lot of ways, I wonder if, had I bid 50, 60 even, if the client would have been comfortable with that. I think a lot of times it's hard as a new freelancer to say, hey, I'm worth so much money. $40 an hour seems like a lot of money, but in the world of freelancing, it's not. You think about the tax rate, you may be I'm in the US, so I have a certain tax rate. It may be different depending on where you're working, but in the US, it's a lot higher. Tax rate is a lot higher for self-employed workers. You don't get benefits if you're working for yourself as opposed to working for a company, so you need to make sure that you cover that in your hourly rate. You don't have stability. You're not guaranteed 40 hours a week, and a lot of times you put in a lot of hours just to be able to find work. And so when you get that work, you need to make sure that that work is helping to pay for the times that you don't get work. And at the end of the day, your price is going to be set by market, but since every freelancer is dealing with those same issues, the market rate for freelancing is just going to be higher than it is for, working a full-time 9 to 5 type job. So, I definitely sold myself short in that instance. I only asked for 40, I ended up getting 45. And given the number of hours I got, that extra $5 an hour did end up paying off a lot. That probably netted me an extra $500 in my pocket, which I don't know anyone who's going to complain about an extra $500 in their pocket. So, I look back and think, could I have asked for more? Should I have asked for more? Should I have thought about this? Don't sell yourself short as a freelancer. You're doing this because you have skills, because you have valuable skills that people want. Don't be afraid to ask for a good rate for those skills, because it's totally worth it. I'll tell you that right now. I'm still learning that. That's a lesson I'm just, sometimes it's hard for me to say, hey, I'm worth this many dollars an hour. And I'm embarrassed, and I end up asking for a lower amount and then regretting it later, when I could probably have asked for more money and gotten more money, and the client wouldn't have thought twice about it. The last thing that I learned from this project was, I think a lot of times, especially on Upwork, it is important to pay attention to getting your contracts closed and getting positive feedback on them. As the contract evolved, I regretted not at some point saying to the client, hey, we've reached a point where we have gone far beyond what the original contract stipulated. This would maybe be a good idea to close this contract and then open a new one. We can open it at the same hourly rate. We can just continue on as we're going. But if we have a new contract, then that indicates that I did do the work that you asked me to do initially, and that will show up as a successfully completed contract on my profile. It would make me, it'll make me more attractive to other people looking to hire me as a freelancer, and that'll be helpful for me on Upwork and just in general. I never did that. The job continued on for multiple months. And then the client one day kind of said, hey, I'm waiting to hear back from some people. Give me a few days. And a week came and went. And he said, I still haven't heard back. And then this client got out of touch. And so, the contract is still sitting there unopened or uncompleted for me in Upwork, I easily met the client's expectations. I easily successfully completed that contract, but it doesn't show up in my Upwork stats. It doesn't show up when you look into me as a freelancer because the contract was never closed. In reality, I probably could have opened and closed 3 or 4 different contracts with this client, which would have definitely helped me look more attractive and look more hireable as a freelancer. And that was especially important given that this was the first contract I took, and this was early on, and I was trying to build up more of a reputation as a freelancer. So I think it's always, that's one of those things where, oh hey, I'm a programmer. I think in terms of code. I think in terms of solving problems like this. And sometimes it's hard to take a step back and think like a business person. And a lot of the advice I'm talking about here at the end is how to think like a business person. You're as a freelancer, you're not just writing code. You are running your own business. You're selling a product, and that product is you. And you need to find ways to make sure that you're protecting that. Protecting your time, making sure that you're asking what your time is worth, making sure that the client is doing their part. The client has some obligation to you. If they're going to hire you on this site, then they owe it to you, if you do a good job, to close out the contract and give you positive feedback. It's always a good thing to ask for, always a good thing to really emphasize. And when you have positive feedback from a client on your profile, other people are going to see that, and they may be willing to hire you where they may not have otherwise. So, just like if you were running a small cafe or something and you wanted to have people leave you positive Yelp reviews or Google Map reviews, it's the same thing. You want to have people leave you positive feedback, and you want to get your contracts closed to indicate that you are capable of completing a contract and meeting a client's needs. I definitely regret not asking at some point. I'm sure the client would have happily done that and then just opened another contract with me and continued on right where we left off. But instead, I now have a contract with hundreds of hours on it that is just sitting open and will probably never be closed out. So that's my like practical advice, my practical, hey, here's how to make it as a freelancer business advice that may not have much to do with Python coding, but is still really important if you are trying to get into the freelance world. All right, well, that's all I have for you. Thanks so much, everybody, for watching this video, for taking a moment to learn. I hope that I was able to help you out. I'm always happy to provide some knowledge to other people who are trying to get into this world. It's a great world to be in. It's one I'm really excited to be a part of. I hope that you mirror that excitement as you get going on it. That's all I have for you. Thank you so much for watching. Have a good day.